Here are the other sample questions from the classwork exercises for the 29th of April. Number 9. The first year of a charity walk had an attendance of 500. So that's your initial amount, which again is A. So I'm going to put A equals 500. The attendance, which is Y, increases by 5% each year. So I'm going to put increase by 5% each year. They'd like us to write an equation, an exponential growth equation, that represents the situation. And it's growth because we're increasing the rate each year. Important to realize how it's given as 5%, so the rate is a decimal, it has to be a decimal. So we're going to make 5% into a decimal. The way we do that is we take 5, the decimal point is already after the 5, and we move twice to the left in order to make it a decimal. The decimal is here, the space is filled with a 0. So the rate is going to be 0.05. That's going to be the rate we use. And now we have to write a growth formula. So the Y is going to be the attendance. And this is equal to the initial amount, which was 500 people, times 1 plus our rate as a decimal. So we're going to add in the 0.05. Be careful to put 0.05 and not just 0.5. 0.5 would be a 50% increase. We're dealing with a 5% increase. Close out your parentheses, and then it's raised to the x power, and x represents the time, the amount of years. So this is the formula that you're going to be using. And the second prompt says, how many people would attend in the 10th year if needed? Round your answer to the nearest person. So now what this means is we have to plug in 10 for x, because x is the amount of years. So Y is going to be equal to 500 times 1.05. I can combine all this together to be 1.05. Raise that to the 10th power because it's 10 years. Use your calculator. 500, open parentheses, 1.05. That includes the initial 1, which represents 100% to start with. And then we're adding 5% on, so it's 1.05 as a decimal. Close parentheses, raise it to the 10th power. This is equal to 814.4. Now you can't have 0.4 people. So what we're going to do is we're going to round this up to be 815 people. We're going to consider that 0.4 as another person. So our answer would be 815 people would attend in the 10th year. And that's how you do that 9th example, the 9th exercise on that worksheet. The other one that I want to show you is an exponential decay, which would be number 15. Number 15 says your car cost $42,500 when purchased. That's your initial amount, A. So A would be the amount that the car cost at purchase, which was $42,500. And it was purchased in 2015. It's important to know what year it was purchased in. The value of the car depreciates or decreases by 15% annually, which means yearly. So the rate is decreasing now by 15% annually. We're going to take 15%, move the decimal twice to the left to make it a decimal. So the rate is going to be 0.15. That's your rate. This is your initial value A. And we are going to come up with a generic formula using the decay model. So y equals, A is going to be 42,500. That was the initial amount of the car. Open parentheses. We're going to take 1. We're going to subtract off, because now we're decaying. We're going to take off the 15% for each year. Raise that to x, which is the number of years. This would be the equation we would use. The next question says, how much would the car be worth in 2022? Round your answer to the nearest dollar. So it was purchased in 2015. 2022, what does it cost? So we're going to use this formula to figure that out. First of all, it's important to realize how x is the number of years. It's not the year itself. So we're not going to put 2022 as the power. We're going to put the amount of years that has gone on from the purchase to now when I want to look at how much it costs in 2022. From 2015 to 2022 is 7 years. So that would be the x value. Y equals 42,500 times 1 minus 0.15. So instead of putting that, I'm just going to condense that and put 0.85. And I'm raising it to the number of years, so I'm going to raise it to the 7th power since 7 years have gone on. Do all the calculations on here. 42,500, open parentheses, 0.85. Raise that to the 7th power. And the output would be $13,624.52. It says rounded to the nearest dollar, so I'm going to round up and I'm going to make that $13,625. That would be the nearest dollar. That's how much the car is going to cost in 2022. And as you can see in questions 9 and 15 on this exercise, these are some real-world situations that use exponential functions.